All right, and we're live. Okay, seems to be so. Let's get straight into the theory of things, right? We're going to be working on some electrical analysis, some circuit analysis. We're going to be doing it in the AC source, so it's pretty sick working with the waves and stuff. Let me just pull it up here. I could literally just pull it up on my phone. The Canvas app is amazing. Ain't gonna lie, it has been made well, right? So let's pull this up and we'll get started. I gotta get up the actual problem, so turn in the lab report. That was clean. We're gonna do some sinusoidal steady state analysis. Alright, some AC sources. Do what? Find a steady state expression for in the circuit using source transformations. We did that one. With respect to terminals of the circuit shown. Alright, this one. This one I have yet to. I guess I'm just gonna start on it, but this one I have yet to. I've tried it a couple times. I ain't got it right, for real. It's on some messed up stuff. Alright. Come on. There we go. Something like that. And 75. This is in polar coordinates, and we have a 0 degree phase shift. Alright, and that's a voltage source. Volts. Put my units. 600 ohms. This is all in ohms, though, right? It's the impedance. These are the impedance values in phasor form. Alright, and then this is the dependent source. Alright, so in order to work this, I would do a nodal analysis, but thus far this has led me to failure every time. I don't know why. We consider that to be V out if this is our ground, right? We have to create a reference node, which is this one here. E is a node, V out is a node. And I mean, these would all share the same current because it's simply in series. So, alright. So what we just set up a node analysis, okay? And then we'd consider this current, that's a current, and this current exiting this node E. Alright, and then V out divided by, what is the magnitude of this resistance? 40 ohms. 40. Alright, so 75, 600, J, 50, that's an imaginary number, right? It's equivalent to I. Same thing, we're just going to use this as to not get confused with the current. Alright, so essentially, so 75, right? So if we're to try to find XY of this, right, because it's a phasor, or it's in the phasor form, therefore we could oh no, wait. Therefore we could, oh no, I wasn't recording. That's too bad. Oh well, no, okay. 75, it's in the phasor form. What the heck? Why does it keep doing that? And we want to convert it to, phasor form polar coordinates, and we want to convert it to rectangular coordinates in order to perform addition. Yeah, that's true, but no, that would be entirely true. Minus E. Maybe that's my issue, is that I shouldn't get rid of that. Maybe that's, wait a second. I think I just figured out what my problem was. Anyways, that would be 75 multiplied by cosine of 0 degrees, which would be 1. 75 multiplied by 1 is 75, and then if you were to add, right, it would be an addition, yeah. If you were to add 75 multiplied by, sine of 0 degrees, you just get 0, right? So on that end, so 75 minus E divided by 600 plus J 150. Okay, right? So 75 minus E though. But my fallacy, the fallacy which has been constant throughout my efforts, is that I don't think if we were to 75 minus, like, what is E? What form is E in? Would it just be rectangular? So it'd just be rectangular form. So simply 75 minus E. But if we're going to do division and I converted these into polar coordinates, because it's in rectangular now, if I were to convert it into polar coordinates, then this would equal 75 squared plus E squared, the square root of that, right? So that's entirely different than what I've been trying to conduct. No, but then what are you saying? We're saying it'd be inseparable? There's no way. So, like, we put these in parentheses. But that's not correct, right? 75 minus E. Oh, no, that's just the phasor form thing. So, it must be maybe that's another fallacy. Yeah, perhaps. Perhaps. Oh, shit. Okay. Oh, there it is. 600 minus. So, okay, so 75 minus E, right? And then this one's going into, so we'll consider that to be positive. Well, that's why we start with 75, right? The direction's that way. This is you. Oh, okay. That's also, wait, a mistake I've been making. No, it's not. No, it's not. No, it's not. I mean, this would still be, because it's going into the node, it'd still be V out over 50. And then we have E minus plus E minus V. Well, this would be actually a minus, right? Because it's exiting the node. So minus E divided by V out, or E minus V out divided by negative J 150. Alright, and then that's the impedance of our capacitor. So now all this equals 0. That's KCL. Alright, so KCL in using Ohm's law, of course. What is bloody yapping about? Cycle. Oh no, it's blurred. Why does it keep doing that? It's circuit analysis, brother. Circuit analysis. So we're solving for the voltage here and here, given this voltage of 75 volts. This is the phase shift of 0 degrees, meaning that the sinusoidal wave is literally just centered with no shift. So it's like if this was the center and this was 0, it's a cosine. Like, we would model it as a cosine. Where's that? I think that's in the center. Anyways, it'd be some wave like that, you heard? And then it'd have an amplitude, right, of whatever. In this case, it's 75. And there's no phase shift. We start at 0, right? The other wave would be symmetrical on that side. All right. So, fuck, that's what it is. But that's our source, okay? So you can have something such as this, or you could also have something like a battery, which is a direct current, okay? That don't look sinusoidal like this. It's not a wave, okay? Well, so, yeah, but there's debate, but just like that simple model, right? So just think of that. All right, right, and then my other equation, because we have E and V out, these are our two unknown variables, therefore we need two equations to solve, okay? And so V out would equal, and the current is going to go in this direction, would equal, I'll write it over here. E minus V out divided by negative J 150. See that plus, well, minus V out divided by 40 equals 0, right? According to KCL. All right, KCL. All right, I'm done. That's Kirchhoff's current law. All right, it's a physical fucking law. You can't really change it. Right? It just is what it is, brother. There ain't nothing you can do about it, okay? Alright, nothing you can do about it. What I've been doing is I've been solving for E here, and then I've been plugging in for E to solve for V out, right? Which would look like this. So we'll separate all of the equations first. 150 equals, that's negative and negative, right? Negative V out, I guess that'd be a positive, so it'd be minus V out over J150, right? And then plus V out over 40. Okay, so if that's the case, now we multiply, so it'd be plus, we could pull that out, that we, how do we get rid of that? I guess you could just do that, make it negative, and then what? No, I don't think that's how that works, so, alright, I don't think that's how it works. Alright, E equals negative V out minus, yep, so equals V out negative 1 over J 150 yard plus 1 over 40, 1/40th. Alright, so and the ordeal here is that, like, brother, I guess I ain't really figuring it out correctly. I'd write E negative 1 over J 150. Alright, so we could put these on top, well, the J on top, and then it'd be like, that would be the, I really want that on top. Yeah, I'd really want the J in the numerator, but how can we achieve that with this side? Would it be a multiplication to this side? Is that possible? It is. One would be J50, and then you have it on this side and that side. Interesting. Let's see that through. Let's just run through a little scenario. Okay, so if we were to, alright, so so if I were to make this positive, right, I'm pretty sure the rule of the imaginary number, which is J right here, would mean that J is in the numerator now, and 150 still in the denominator, of course, right? So now it's just a coefficient of 150 over, or 150th, holy smokes, J divided by 150th, yep. Alright, V out, and then what would be the product of this? Plus 40, 150, that's not achievable. We'd still have to find a common denominator, but also we'd have to implement J, the imaginary number, so it'd be this multiplied by that. Well, whatever it is, yeah, whatever it is. Okay, negative 1 over 150. Multiplied by what? What's the common denominator to get that on top, and then we could do it like that. I think it would work. Yeah, it would. Alright. Wait, no, so just 150, what, like 150, I guess multiplied by 40, and then we can reduce it. Wait, so 150 divided by 40, or times 40, 150 J 50, 40. But that's not necessary. 150. Oh shit. Yeah, okay. Not 7, 150. 6,000. Negative 6,000. Yeah. Oh shit. Alright, yeah, something like that. Okay. 40 plus negative J 150 divided by negative J 6,000. So like this, now we can multiply this to this side. Why not? And then that would become a real number, right? Because the imaginary number squared would be negative 1. So negative, yeah, 6. Okay, so negative, literally negative 1, but that's also a negative. Like that. Multiplied by negative E 150, 6,000. Okay. Equals that. Negative j. Multiply that, become -1. -1, negative, right? Of course, positive. E 150. 6,000 divided by 150. 40. E 40 equals 40 plus J 150. Okay, E 40 equals 40 negative J 150. Alright, now how do we carry on here? Is right, equals 40. I guess we just wait. Where's V out? Oh shit, we forgot V out. That's okay. Wait. Oh, V out's multiplied by this whole thing though. Right, okay, now we have these two. So we just simply divide by 40 and we can plug V out into this equation. Okay. E equals 40 plus negative J 150 divided by 40. Yeah, okay. So let's plug V out into this equation up here. So, and well, no, wait, no, I mean E. Yeah, there it is. Okay. Ooh, oh, whoa. We should solve. No, yeah. We should solve for V out. There's oh no, there's two. Never mind. There's the same amount of E's and the same amount of V outs. It's not necessary. All right, we'll move on. We'll keep going. All right, 75 minus, oh man, negative 40 plus, okay, I'll make this a subtraction. There's no purpose in that. Minus J 150 divided by 40, V out. Okay, all divided by 600 plus J 150, and that's my imaginary number J. Similar to I in mathematics, right? V out over 50. Because we're solving for V out, and then again, we're going to plug it in here. 40 plus, minus. Let's get it up to minus J 150 divided by 40 V out divided by, V out minus V out divided by negative J 150. Equals 0. Alright, so 75 minus 40 divided by 40 is 1. 75 minus 1 minus J 150 divided by 40. 150 divided by 40. 3.75. Okay, J 3.75. In the denominator, of course, 600 J 150. All right, it's a lot of numbers, right? A lot of numbers, a lot of calculations, but we're a big calculation guy. So we're gonna keep rolling this train in motion. This would still be in parentheses, and that would be V naught. So we would distribute it, and then we'd have a complex equation for V out. And then we solve for, well, no, we still want to solve for V out. But then that really wouldn't do anything interesting. I don't know, because that's not really getting me anywhere, right? I guess I could divide by, maybe it could become a division. Yeah, that's what it's gonna be. Okay, never mind. Maybe, I don't know, let's see, let's keep going. right? 40 over 40, so it would be 1 minus j, again, 150 divided by 40, same thing, 3.75. Divided by, oh, that's that whole thing. V out minus V out. Now I could distribute and combine them and then just redo it. So V out 1 minus, oh, V out minus V out. Okay, just be gone. Wait, but this would remain, so it'd just be J 3.75 V out. Okay, wait, really, truly? And then J, negative J, 150. Right, so J 150. Shit, I think that would just be a real number. If I'm here, let me put it in though. So 3.75 divided by wait, what? Negative J 150. Negative 562.5. Wait, what? Wow, why is it so much? Wait, what? That's crazy. Why is it so much? I literally did 3.75 divided by 150. But of course, right, the imaginary numbers are in there, but 562.5? That's what? Okay, there it is. There it is. Yeah, maybe made it positive by flipping that one. Became multiple, then it became negative again. Oh yeah. Okay. 562 though, that's it. V out. Wait. Oh, it's not even. 562.5 equals 0. I had to write it down so I didn't forget. It was on the calculator too. I guess I could have did that. Whatever, guys, whatever. But it all equals 0, right? According to KCL. Okay, we're using Kirchhoff's current law. Okay, it's vital here that it sums to 0. All right. Okay. Again, V out over 50 plus. All right. Now we got this equation here. So it's looking fucking ridiculous. All right. It's looking ridiculous. But this would be separated, and then we'd have that. Let me see how that looks. Right, if we did that plus, and then that would be involved. This still has a V out in it though. Yeah, just like that. 75, 600. Let's. And how could we just do that? 600. Come on, brother. 600 plus I 150. Okay, and then we get that shit. Alright, crazy numbers. Alright. Do I even want to write it like that? Minus 1. Yeah, but that's a part of that, so. Then we could. No, it's not achievable. That's the thing. That's the goal. Multiply. Okay. Okay, yeah, that's actually fine. Okay, this is what I want to do. I want to get everything to this side and then keep just this equation on this side and then multiply by that. That's what I would want to do. Wait, but do I want to get it all up? Look at these two could be, oh, that's the whole point of it. That's the whole point of it. I don't want to separate this. That's the whole point of it. Alright, so I need to isolate just this fraction on this side and move everything to that side. So it looked like equals negative V out over 50 minus, oh shit, but that was still correct. Negative 5 minus 5, 62.5 V out. Right, okay, so we could even combine these two and then multiply by that, and it'd be even better. Truly or not? Nah, we'll just leave it like that. Okay, and then this whole thing multiply by 600 plus J150, right? Multiply by that equation, and this is going to equal 75 minus, you know, this whole equation here, J3.75 V out. Alright, now we have this negative V out, 600 plus J150 divided by 50 minus, okay, V out 562.5 multiplied by 600 plus J150. Yeah, like that. Double parentheses, right? Because we had the two beginnings and then we need the two ends. Alright, that's looking all very good. I believe this is correct. Hopefully it's the right path. Alright, minus equals. Oh, I didn't write that down. Didn't I just write that down? Okay. Yep. Yeah. 75 minus. So we're going to add that. So 75. Okay, we're also going to add that. 75 plus 1 minus J3.75 V out. Alright, now we have all our expressions for V out. Now we're just going to use laws, distributive laws, right? So we're going to pull V out, in brackets, negative 600 plus J150 divided by 50 minus, minus 5, so okay, yeah, this whole expression, 562.5 multiplied by 600 plus J150, right, and then plus, 1 minus J3.75. Yeah, there it is. Okay, that's the expression. That one plus, oh, wait a second. No, that was the end of that expression. Yeah, that's my bad. Let me distinguish these a bit better. So, in parentheses there, plus 1 minus J3.75. Yeah. Close the bracket. There it is. V out equals 75. So that means 75 divided by all of this. Yeah, I guess so. Right, so V out equals 75 divided by, well, I guess we should center it up a little bit better. Am I right? You know what I'm talking about. Center it up just a little bit better there now. So it's going to be 75 divided by this whole expression here. Like, fuck me, man. Alright. I shouldn't curse, but, fuck. Like, look at all of this, man. Are you kidding me? And I keep dropping things. It's not, I just dropped a wrench, luckily. I've tiled too, so luckily that didn't go wrong. But I dropped a wrench earlier. I dropped my calculator. I was actually a bit afraid. Okay, it's the calculator. It's the precious computer which does most of my math calculations, because look at how tedious this is. And yet there's even more numbers involved than you can even perceive right now. You don't even know, because this is just the beginning. We just got started. Oh my gosh. Okay. But it's all good. The calculator was good. Alright, Alright, I don't know. I'm not gonna. Do I need to write all that out? Let's write it out for calculator's sake. It'll be easier to type in. Okay. So V out equals. I need to be in. What kind of mode am I in? I'm not even in this mode. So let's do it. So 75 divided by. I don't think I closed it. I didn't close it. Yeah, it's still new though. Okay, so final result negative 2.09 e to the negative 4. E to the negative 4 plus 5.23 e to the wait, right? No, it really is just e to the negative 5. J, of course. That's the imaginary part. Okay, so V out. Alright. Okay, now we just have to convert this to polar coordinates, and we can, we'll know whether our answer is correct or not. Okay, alright. Oh, shit, okay. Oh, and the way that we do that is, so none of this was actually phasor form, so we shouldn't have rho V out like that. We should write it like this. Wait, no, it was phasor form, just rectangular coordinates. That's true. Never mind. So we'll go like that. Equals. Okay, so square root of 2.09 e to the negative 4 squared plus 5.23 e to the negative 5 squared. Phase angle inverse tangent or arctan of 5.23 e to the negative 5 divided by negative 2.09 e to the negative 4. Yep, okay. Equals, alright. Whoops, I forgot how to start it. Can you see that? Yeah. Alright, square root. Yo, here we are though. Saito. Is that how you say it? Alright, square root 2.09 e to the negative 4. Come on, bro. What happened? Square root of 2.09 e to the negative 4 squared plus 5.23 e to the negative 5 squared. Ooh. Whoa, no. I should have known this was wrong. How? Fuck. No. Why is that the case? Oh, fuck. Alright, no. Something about it ain't right. Okay, what'd I say? I said E minus V out. Can we see that? Yeah. Alright, E minus V out, right? So, equal divided by negative J, 1 over 50. Negative V out divided by 40 equals 0. E plus Negative, positive, minus V out 1 over 50. 40. Either negative 1 over 50, J50 equals 4 V out negative 1 over 150, 40 plus. 6,000, negative E, 150, negative 1. Yeah, because we put it under a common denominator. We added the numerators and then we multiplied this side by 40. 40 be a division. 40 plus negative J 150 V out E. I mean, that's it. Nah, that's it. But is that logical sense? It sure is. It sure is. It logically makes sense. Nah, yeah. I just think the addition on the way I've been typing it in my calculator, something must be wrong. Is it not? So let's try this. Negative 600 plus. Oh my goodness. I can't there's a crazy noise going on outside right now. I can't focus. Shit, not 5. 50. Okay, so 75 divided by negative 12 plus 3i. Or 3j. I like I though. I do like I, but like, you know, we don't want to get mixed up with the current, right? And this is just standard way of electrical engineering is to write it with a J. So this is the way we'll continue. But the I just looks nice, you know what I mean? So we're back to this. We're looking at this equation again. We can just disregard this one. It's not correct. We shouldn't have this low of numbers. It's a voltage, and we have a supply of 75 volts. I mean, like, this should be way higher. Yeah. Minus. Okay, we have that value. Wait, well, not necessarily. And is that correct? Let's go back to that. Because how do we get to this equation? 600 plus 150, J 150. Because we added these two, and negative, be positive, V over 50. Positive. That's currently, because we moved it to this side. That being a, okay. Became a positive, it'd be a negative also. Is it a negative? 3.75. Okay, there's some, wait, no, because it was 3.75 divided by negative J 150. Do I absolutely have to convert, when in the phasor form, do I absolutely have to convert the rectangular coordinates to polar coordinates in order to do a division or a multiplication? Like, must I actually have to, like, you know what I mean? Do I have to do that? But, like, let me look it up. Let me look it up real quick. Because I've always been speculating. I say that, like, I guess I've been doing it a lot, okay? But it's not really giving me much success is the thing. Unless unless I'm doing something wrong, which is probably happening. But let me see. Must I, let's ask AI, display. No. Oh, I see. Alright, must I, well, hold on. Okay, must I convert, like, do I put some emphasis on it? Do I absolutely have to convert rectangular coordinates to polar coordinates of the phasor voltage when performing a multiplication or division? Question mark. No, you do not have to convert rectangular coordinates to polar coordinates because you can multiply or divide complex numbers directly in rectangular form. However, doing so requires more steps in complex math. Use the FOIL method. Remember that j squared equals -1, so the real part becomes, and the imaginary part becomes, this takes 4 separate multiplications and an addition or subtraction. AC minus BD, and the imaginary part becomes the real part. This takes 4 separate multiplication and addition or subtractions. Dividing in rectangular form, set up fraction. Multiply the top and bottom by complex conjugate of the bottom, which is C minus JD. Simplify the denominator into a single real number. Expand the numerator using the FOIL method to get the final real and imaginary parts. If you like, I can show a quick numerical example. What happened? So the complex conjugate, which is C minus JD. Okay. So that's not. Wait, is that what I got going on here? It's kind of what I got going on here. Oh shit, it really is. All right, so let's try this then. Let's take it to this point. New line. V out equals 75. Was I gonna do something with that? No, I don't think so. Yeah, I just have to do that. Yeah, okay. That's what I was gonna do. Whoa, how did I do that? Wait, so what? Didn't I just do that though? Yeah, so -12 plus 3 for this one. That one's just huge, is the thing. That one, why is that one so big? I mean, shit, guys. I mean, shit. Looks like we got a hefty problem on our hands. Let me transition back over here now. Alright, well, this is what we need to abide by. Wait, I mean, that is what I'm doing. I am abiding by this. I don't understand what's the problem is. It's actually pretty ridiculous if you would ask me. You know what I'm saying? It's not really giving me much explanation. So, what do we do? What do we fucking do? Okay, we're gonna pull it together. We're gonna fucking, I don't know, should we start? Oh, fuck. Should we start from the beginning? I fucking hate starting from the beginning. No, let's not. Oh, shit. Man, it's just gonna be so much better. Alright, let's just see real quick. Right, 75 of this bullshit minus E divided by 600 plus J 150 plus B out divided by 50. Will it be, E minus, will it be 0 minus E? This would be negative, right? Because when it'd be 0 from here, this is 0, so it'd be 0 minus E divided by negative E. V out divided by 50. Wait, no, not like that. Wait. No. I'm an idiot. The way we've been doing is correct. I'm an idiot. It's a dependent current source. Like I'm stupid. Right. So minus, plus minus, E minus V out divided by negative J 150. All right, bro. What am I missing? I don't want to do all this shit again. Oh, 75 minus E divided by... I literally have a row here, so what's the problem? Like, what am I... I have a row right here, so 6... yeah, plus V out over 50 minus E minus V out divided by negative J 150 equals 0. That's so true. That's so true. E minus V out divided by negative J 150 minus... What is that? Yeah, minus V out divided by 40. V out divided by 40. That's be 0. That's V out. I want to solve for V out. Yeah. Okay, yeah, negative J 150. E negative J 150. Right, we take that away. So that was an addition. Well, negative V out. Oh, that's a positive. It'd be negative, yeah. Duh. Negative V out over J 150 plus V out over 40. Okay, that looks accurate. That looks accurate. E. Okay, what's the problem here then? Oh man, this is the hardship, guys. This is the hardship. We're losing it. See, it's such big numbers. I mean, no, it just can't be accurate at 562. Yeah, that's okay. That's the problem. Well, shit, not that. This. But oh, it was is negative though. Alright, I found it, guys. I think I found my error. It was this guy. But did the negative carry through? Negative 0.025. Negative 0.025. Negative. This is the minus. Is that where that comes from? Minus. Yeah, that's where it is. Okay, it's in the minus. It's in the subtraction. All right, 0.025, 0.025. Okay. Oh, well. I guess I could have kept that, my bad. Okay, 12.3 plus, fuck. Negative 12 plus 3i. Yeah, fucking IJ. Sure, sure, guys. IJ, whatever it be. Hey, bro, hey, nice hand. Nice hand, bro. Thanks. Thanks, G. Bro. 3G. Alright, minus 0.25. Alright, let's do this. 0.025. Come on, bitch. 0.025 multiplied by 600 equals 15. So minus 15. Nope. Minus. Also, we're going to distribute the negative. J 150 multiplied by 0.025. 3.75. Yeah, just like that. Plus, wait, 3.75 J plus 1 minus J 3.75. Ooh, that's also a subtraction? Damn, that sucks. Okay, and then we also have a 3 right here. 150 divided by 50. Negative 12, right? All this, so 75 divided by all of this. 75 divided by all of this. Can you believe it? Can you actually believe that? Can you actually believe that? I appreciate the chatters though. That's what's up. Got some looking like a particular group with those emojis. You know, looking like you have a particular affiliation posting those emojis. You know what I mean? I'm all for it. I'm all for America first. You know what I'm talking about. Alright, well, shit. Well, all of that's accurate. Is it? Let's just add it up then. Plus 3 I minus 15 minus 3.75 I plus 1 minus 3.75 I. 75 divided by negative 26 minus 4.5 I. Okay, so now at this point, now we would multiply by the complex conjugate. So 75 multiplied by negative 26 plus 4.5 I divided by negative 26 minus 4.5 I multiplied by negative 26 plus 4.5 I. Man, I wrote an I again. Anyways. Equals V out, right? We're solving for V out. Shit. Okay. V out. Alright, now we're progressing. This is better. This is much better. Alright, now we're getting back into it. Now we're fucking let me cook. Alright, let me cook. Okay, so 75 multiplied by, shit, come on now. 75 multiplied by negative 26. Ooh, yeah, we could just, 75 multiplied by, in parentheses, negative 26 plus 4.5 I. Is that a 4.5? It really is, huh? Equals 19.5 plus 337.5 J. Why is that such a large number? Are you kidding me? What? 45 or 4.5. 75 times 4.5. It is a big number. Shit, seriously? Wait, what? Why is 96 not big? Multiplied by negative 26. Wait a second. What is going on here? What is going on here? I guess we're going to divide by all of this too. Right? Yeah. So, I don't want to oh shit. Do I distribute it? Hold on, let's divide. So 75 okay, I got an idea. So 75 multiplied by negative 26 plus 4.5 I parentheses divided by negative well, it's gonna be and then off to a side note. Oh shit, now I gotta here, let me use my phone so I don't ruin this. Abo okay, 26 squared, right? 26 squared, 676. So off to a side note, 676, because it's going to be positive. We got two negatives. The middle terms are going to cancel. That's the purpose of the conjugate. And then negative 4.5 multiplied by 4.5 is going to be a negative number, which is 4.5 squared. 4.5 squared. 20.25. And it's negative. And, okay, and then the I squared or the J squared is going to become negative 1, and that's going to make it a positive. Just this number, that's going to be, wait a second, and we have a 4.5 there. Yeah, this is meant to be like that. In parentheses also, we need to put this, anyways, for distribution. Right, negative 26 multiplied by negative 26, that's, did I write it down? 676. But then we have a negative 26, yeah, plus 4.5. Negative, no, that's not that. We have a negative in it. Oh, okay, that's what I was doing. Fuck, dude. All right, negative, yeah, negative number minus positive, plus, 20.25. Oh, and 676 plus 20.25 is 696.25. So we have 75 negative 26 plus 4.5 J. That was really bad, but whatever. Divided by 696.25. Okay. Equals V out. V out equals. And it's a long problem, isn't it? Damn. It's a long problem, isn't it? Okay. Right now we're doing this divided by, and I just solved for that, 696.25. Nah, that still ain't it. No, it's just not fucking it. Holy shit, dude. How? Yeah, as you can see, this shit's pretty fucking rough. Alright. Whatever. Dude, this shit still ain't fucking right. Oh. I don't get it. All of the logic is secure. I'm telling you. It's secure, but I mean, obviously it's not because it's not working. Alright, you know what? Let's just give AI a little ask, just a little question, okay? And because we need to figure this out. All right, it needs to get done. Need to know how to do it. So a little question. Okay, nothing big. Nothing big at all. Just roll on over there. Fuck, guys. Fuck. But there's more to be done, and we have all the time. So let's persevere and figure out how to do it. I'm simply missing something, but I don't know what. I don't know, maybe I could try solving it another method, not nodal analysis. I could give that a shot. I guess let's do it. Let's do it before I resort to AI, right? Because AI, man. Who wants to use AI? Honestly, it might just be the death of us. Okay, another method. Okay, so we consider E. Yeah, so we're gonna do mesh analysis. Our independent variables are V out and I1 and I2. So we have three unknown variables, and we have two equations. We need one more equation. Which this is like something about a super mesh type deal. We'd say, oh yeah, that's what we'd say. We'd say I1. Nah, we'd say I2. Yeah, because it's going in the direction, the dependent current source is going in the direction of I2. So we'd say I2 minus I1 equals V out divided by 50. Right, and our expression with V out, yeah. Wait, no. And that's not V out. Why'd I make it V out? Shit, I'm retarded. I'm sorry, I'm stupid. That's not what we're doing. There it is. It's more like that. It's more like that, okay? All right, V. Okay, we can solve for V out. This is V out. That's the term, but we want it in terms of the current for right now for the mesh analysis. So therefore, what should we plug in? We have I2. We have just as many I1s. But we'll plug in for I1. So I1, because we want to know I2 for the purpose of solving for V out. So I1 equals, we'd add it and then subtract this term. So I2 minus V out over 50. Okay. And that's I1. So 75 minus 600. Is this the result? Is this the result of all this? Oh no, we're doing the mesh analysis. 600 multiplied by wait, what? Oh, I1. Negative V out divided by 50. I2 minus J150. Negative V out over 50. I2 minus V. Yeah, I guess this is the way to do it. V out. V out. I1. We still have 3. Wait. V out over 50. Yeah, we have V. Interesting. Wait, V out over 50. Oh. Okay, and then V out. Oh, okay, and then V out equals I2 40. Yeah, so okay, so I2 40. Wait, yeah, V out equals I2 40. So 40 minus 50, I2 minus 40 divided by 50. Wait, I2 minus 40 divided by 50. 0.8 I2. I1 equals 0.2 I2. Nah? Shit. Okay. That should be it. Alright, so really 600 multiplied by 0.2 I2 minus J150 0.2, what was it again? I2 0.2 I2. Alright, minus V equals, no, I don't want to do it like that. And then just this equation. So, and then yeah. I really like this. V minus, well, let's just make it a plus. Plus J150 I2 minus 40 I2 equals 0. Okay. So 0.2 multiplied by, wait, 0.2, wait. Can you see that? Yeah. 0.2 multiplied by 600. 75 minus 120 I2 minus Alright, my two equations. Now I can solve. Alright, let's just add these two equations. These will cancel. Then we can solve for I2 as imaginary in it. So 150 minus 30, 120, 120J, negative 40, negative 120. Negative 160, negative 160 I2 plus, be positive, equals negative 75. So, negative 160 I2 equals negative 75 minus 120 J. Negative 75 minus 120 I2 equals 75 divided by 160, 0.468. Shit, we could call that, let's call it 469. Plus 120 divided by 60, 160, 0.75. Okay, I think we're on to something here. So now we should do the magnitude of this. So I2 in phasor form, well, magnitude, I guess that could have been, if that is in phasor form, square root of 0.469 squared plus 0.75 squared is 0.885 amps. Phase inverse tangent of 0.75 divided by 0.469. 57 point, let's just call it 56. 56 degrees. 56 degrees. Okay, my numbers again. Alright, I2. Now for VL equals I2 multiplied by Z R40 equals 0.885 amps multiplied by 56 degrees multiplied by 40, 0 degrees. Yeah. Just that. So 40 multiplied by 0.885. Oh man, holy shit, guys. I'm literally doing everything right. What? And it's just not. There's something entirely different needed to be done. I1 equals I2, I1, I2 going in this direction, I1 going in this direction, I1 minus, or I2 minus I1 equals V out divided by 50. I1 plus I1 minus this, I2 minus 0.8. And then I2 minus 0.8. V out equals I2 multiplied by 40. I2 over 40.8. 40 divided by 50. 40 divided by 50.8. And then 1 minus 0.8 would be 0.2. $75 minus 600 minus negative positive. If it's a source, right? That doesn't necessarily, that doesn't mean nothing. It's going in that direction, so yeah, let's still be opposite. It still cancel. It wouldn't matter. No, it wouldn't. Yeah, it would. Yeah, it would. Still be opposite. So it doesn't matter. Alright, I guess let's resort to AI. Unbelievable. I can't believe it. Shit. Forgot how to do it. That ain't it. Yeah, it's been a minute. I don't know what I'm doing wrong. Bang. Okay, let's see how he does it. Hopefully he rendered it correctly. Let's see. So V out minus V1, V out minus V1. Let V1 be the node voltage between the 600 plus J150 impedance, the dependent current source, and the ohm capacitor. The negative, okay, the dependent current source and the, okay, yeah. So that's V1. Okay, so first of all, V out minus V1 divided by negative J150 plus V out. V out minus V1 plus. So it's saying both go in. That's positive. This is positive. No. It's saying it go like this. V0 minus V1 plus. Oh, no, and this is going out too. Interesting. This is going out too. Okay. Plus. Where were we? Oh, no. Oh, no. Oh man, I can't really think of where to go. Oh shit, where was I? Where was I doing all that? Just now. I was right there, 50 over. Right. VL. Yeah. Oh, I gotta see something though. Quiz is due tomorrow. Um, take a short break. Like, we didn't do that. Are you kidding me? What? All my previous arithmetic and calculations were literally like what? What the fuck? What am I doing wrong? Where did I go wrong? I gotta see. For this calculation, at least, where we define E. Where is it? Right here? Like, what the fuck? So, I should have did that. Okay. To get a J in the numerator. Okay, and I take 150 with it. Well, there's my problem. Took 150 with it. But I didn't do it here. No, that was wait, what? Oh, yeah, but I didn't do it here. I did it here, but I didn't do it here. That doesn't make any sense. But there it is. That was my mistake. Okay. Now we have this. Let's see what their other equation is. Multiplying the entire equation by 150. KCL at node 1. I don't know why it's doing current in a weird direction. Saying all the current's coming in this direction. It's odd. I wouldn't have done that. V out over 50. Negative V out over 50. True. Plus V1 minus 0. Or V1 minus V out. Whoa. So the node is always positive. I didn't know that. Wait, what? That motherfucker ain't right. We got over 50. KCL at node 1. That'd be V1. Oh man, I got the right answer though, so it must not be wrong. Wait a second. Oh, because it's. Duh. Fuck. Duh. Okay, I see two problems, I think. So let's run it back. Let's genuinely run it back. Shall we? Shall we run it backeth? Backeth to the beginning. I know, it'll focus eventually. Maybe some year. I literally gotta do this shit, okay? So what the fuck? What's it to you? I literally have to do this shit. Alright, so I would much rather be doing other things, more entertaining things. Okay, trust me, trust me. I'd rather be working on a model in CAD, or simply drawing, theorizing a robot. You know what I mean? Like I have certain stuff that I'm working on projects. Okay, I'd much rather be doing that than this. But this is practice that is needed, obviously. I mean, geez, just look at the mess that we're in. Obviously, and if you do a little rewind, you'll see the mess that we're in. Obviously, so. But we're gonna get through it eventually. We're gonna figure out everything and how it works. That is the goal. So I've discovered 2 fallacies in my methods, right? Let's see. I'll explain them once we get there. Let me define this. Current's going in this direction. We got V out divided by 50. Okay. Just got a little burst of energy there just now. Alright, and then we got 40 ohms. Okay, we got J150 ohms. Alright, 600 ohms. Okay, I think I'm feeling it now. Right, Mr. Krabs. V1, V out. Okay, right, that's this node. That's our ground, and this is what we want to find the Thevenin voltage for. And then we're going to find the Thevenin equivalent resistance also. Okay. Okay, numbers, yeah. Alright. So, I don't know, it shouldn't matter the direction, though. The direction should not matter. Right, because we're finding the mesh currents. Wait, what did he, wait. Right, okay. 75 minus V1. Well, no. If I'm doing the node analysis, I want to do node analysis. Therefore, yeah, I need to define currents. So, I want to define currents going in this direction. So 75 minus V1 divided by 600 plus J150. Alright, he's going in, so addition. But that's the way, so V1, that's the thing. If we're looking at this node, V1 is the one that can't be negative. He's the one that can't be negative. That makes sense. Why do we go with that to that? Wouldn't matter. Whoa. Wait. Should it not matter? Let's look at our previous one again. No, I'm just gonna have to wait. I'm just gonna have to look at that. Oh, it's making a comparison between it. V out, yeah. So V out minus V1, V out minus V1. So current's going in that direction. That's true for mine. V out minus V1 plus V out over 1. Or over 40. V out divided by 40. But it's positive. And it's positive. So it's out. Okay. And then V out. Yeah, that's the solution for the rest of it. Now the next equation is V out. Or V1 minus 75. Minus. So positive, negative. Negative. Plus V1 minus V out. Because it would be negative V out minus V1. Okay, sure. No, it is. It's equivalent. So, oh yeah. Wait, and that's due to, well, that's not really the matter. That's not the matter. It's this. Okay. So, that's positive. So V1 minus 75 divided by 600 plus J150. Okay. Minus V out over 50 minus V out minus V1 divided by negative J150. Alright. Plus V out divided by 40 equals 0. Okay. V1 600 plus J150 minus 75 divided by 600 plus J150 minus V out divided by 50 minus V out divided by negative J150. Whoops, that was the wrong thing. J150 minus plus V1 divided by negative J150 plus V out divided by 40. Okay, yeah, I would want to do that. Yep. So V1 divided by 600 plus J150 equals positive 75 divided by 600 plus J150 plus V out over 50. Actually, we should collect these V out terms, right? And we should put them under a bracket. Make it much easier to perceive, right? Because we're gonna need to do this as cleanly as possible, right? It gets real dirty and real hairy with all of the equations and all the numbers and stuff, parameters. So we don't really want to do that. We don't want to mess it all up. Otherwise, it can become disorganized and difficult to actually calculate. All right, so added, right? All this equals 0. Added. Oh yeah, we're gonna do the V out. So 1 over 50. 1 over 50 plus 1 over negative J150 plus V 1 over 40. 1 over 40. Okay, that's the end of the bracket there. Plus V1 over negative J150 equals 0. Yeah, just like that. Right, so, and then I multiply that. So V1 equals 75, right? That would just cancel. Plus V out. Let's do this. And it'd be, so what's 1/50th? 1/50th plus 1/40th. Alright. So 0.045 plus, and then 1 divided by 150 is plus 0.0067 J. Alright. Plus 0.0067 J V1 equals 0. Okay, that's it. Alright, looking at this one now, V out minus V1 divided by negative J150 plus V out divided by 40 equals 0. So let's solve for V1. Let's solve V1. So J150, so V out, so J150 V out. J150 V out minus J150 V1 plus 1 divided by 40 equals, no, fucking pulled the 150 up. That's not correct. 1 divided by 150 is 0.0067. So J V out minus G 0.0067 V1 plus 1 divided by 40, 0.025 V out equals 0. Okay, so V1 plus, just add it to that side. So V1 equals minus V out negative 0.025. 0.025 minus J 0.0067 divided by J 0.0067. Yeah, okay, that'd be it. So, yeah, we should be able to compute that now. Negative point, let's put it like this. So, negative 0.025 minus I 0.0067 divided by J I 0.0067. Says negative 1 plus 3.73. I don't think that's true. I don't think that's true at all. I don't think that's right. Oh, V out. I don't think that's right. Negative 0.0025. Shit, dude. V1 equals V out, V out, V out. Alright, I guess let's plug that in. So, negative 1 plus 3.73 V out. Oh, this whole equation though, right? Yeah. V out equals 75 plus V out 0.045 plus 0.0067 J plus 0.0067 J V1 equals 0. Oh, yeah. Okay, so negative 1 plus 3.73 minus 0.045 minus 0.0067 J minus 0.0067 J. Oh wait, oh shit. Wait, no, that would be, but that has a multiple, which is this V1. So it'd be a multiple of that. Yeah. And then we could subtract it. Multiplied by negative 1 plus 3.73 equals 75. Yes, there it is. So negative 1 plus 3.73. Oh, that should have a J, right? Yeah, but negative 0.025. Negative 0.025 minus, negative 0.025 minus I 0.0067 divided by I 0.0067. Yeah. Nah, that looks like booty. There. So negative 1 plus 3.73 minus 0.04. Oh wait, I forgot the minus 0.045 minus 0.0067 minus 0.0067 multiplied by negative 1 plus 3.73 I, mother trucker. That's awesome. Wait, and this is like V out? Yeah, V out, right? Yeah. So 75 divided by this. And then the square root of 5.228 squared plus 18.780 squared. Bro, that's still not fucking it. It's really close, but it's still not fucking it. Okay. V out 4 minus 3. You got 4 minus 3. V1 equals 1 minus 3. 1 minus 3.75. How? Why is mine switched? How? Dude, what the fuck is wrong with my math? Multiply by... Shit's starting to fucking rage bait me, bro. Starting to drive me crazy. V1 minus 75 over 600 plus J150 minus V out over 50 plus V out over 40. V out, V1, V out minus. V out minus V1. Negative J50 plus 1. Okay. Yeah, so instead we solve for V1. Oh, wait. Just kept it in that form. What does it matter though? So it's really just